Now we have the coordinates of both s and t, so we can use the gradient formula. Let's say that s is 0.1 and t is 0.2. So we can say the gradient m of st is equal to 3 minus 9 over 9 minus negative 5 becomes 9 plus 5. 3 minus 9 gives us negative 6 over 9 plus 5, which is 14. 6 and 14 are both divisible by 2. So we get negative 3 over 7. Now that we have the gradient for st, we can find the gradient for ud. These two lines are perpendicular, so the gradient of ud will be the negative reciprocal value. So we can say the gradient m of ud is equal to the gradient of st is negative, so ud will be positive. Now we can take the fraction 3 over 7, flip it, and we get 7 over 3. This is the gradient of line UD. Now we can move on to part C. Show that 2PQ is equal to ST. To show that ST is twice the length of PQ, we first need to use the distance formula to find the distances of ST and PQ. Let's start with ST. Let's say that S is our first point and T is our second. So we can say the distance of ST is equal to 3 minus 9 in a bracket squared plus 9 minus negative 5 becomes 9 plus 5 in a bracket squared, all under a square root. 3 minus 9 gives us negative 6. Put this into a bracket, square, plus 9 plus 5 is 14. Put this into a bracket, squared, all under a square root. Negative 6 squared is 36, plus 14 squared is 196. Put this under a square root. Finally, 36 plus 196 gives us 232 under a square root. Now we need to compare the lengths of ST and PQ, and it's difficult to do this with surds. So let's open our calculator and we can say the square root of 232 is equal to, put this into decimal form, and we get 15,23154 and so on. Now we don't want to write down the whole number, so we can write our answer as 15,23 to 2 decimal places. Next we need to find the length of PQ. So let's make some space, and we can make a note of the length of ST over here. Let's say that P is our first point and Q is our second. So we can say the length of PQ is equal to 1 minus 4, close the bracket, squared, plus 4 minus negative 3 becomes 4 plus 3, close the bracket, squared, all under a square root. 1 minus 4 gives us negative 3. Let's put this into a bracket, squared, plus 4 plus 3 is 7. Put 7 into a bracket, squared, all under a square root. Negative 3 squared is 9, plus 7 squared is 49, under a square root. 9 plus 49 is 58. We can put this under a square root. Again, let's take our calculator and we say square root 58 is equal to, change this to decimal form, and we get 7,615,773,106. Now, we don't want to have to write down all of the digits after the decimal place. So it's always a good idea to round off our answers. But rounding off during a question can make your final answer incorrect. So let's round this answer off to 4 decimal places because we haven't yet finished this question. And we get an answer of 7,6158 to 4 decimal places. This is the length of PQ. So to find 2 multiplied by PQ, we say 2 multiplied by PQ is equal to 2 multiplied by 7,6158. Now we can take out our calculator. We already have the value on the screen. So let's multiply by 2. And we get, let's put this to decimal form, 15,2315. Round off to 2 decimal places, and we get 15,23. Now we can see that 2 multiplied by PQ is 15,23 to 2 decimal places. And we already found that the length of ST is also 15,23. So we can see that 2PQ is equal to ST. And now we can move on to part D. Prove that PQ is parallel to ST. If PQ is parallel to ST, then these lines will have the same gradient. In part B, we found the gradient of line ST is negative 3/7. So let's make a note of this down here. So to prove these lines are parallel, all we need to do is use the gradient formula to show the gradient of PQ is also negative 3/7. Let's say that P is our first point and Q is our second. Now we can say the gradient M of PQ is equal to 1 minus 4 over 4 minus negative 3. 1 minus 4 gives us negative 3 over 4 plus 3, which is 7. These gradients are the same. So as our final answer, we can say the gradient of PQ is equal to the gradient of ST. So PQ is parallel to ST. And now we can move on to part E. Determine the coordinates of point D. From the question and the diagram, we can see that UD is perpendicular to ST. UD runs from the tip of the triangle over here down to the base on ST. The only way that these lines can be perpendicular is if UD cuts ST in half. In other words, point D lies in the middle of S and T. And this means that D is the midpoint of ST. So we can use the midpoint formula to find the coordinates of point D.